Hey guys, my name is Current. Now I'm a 300 level medical student in University of Ibadan. So I'm launching a YouTube channel basically for O level. Now this will also be helpful to those of us writing Jamb and Post-UTME. Starting with wave, intro to wave, then go to light, then go towards sound. So we'll be taking it gradual process. So you guys can follow up and please make sure you subscribe. Starting with wave. So introduction to wave. So we're looking at definition, classification, terminologies, and progressive wave properties and what calculation. So these are our outline that we'll be using today. So now let's start with it. Now, wave can be defined as a disturbance which travels from one point to another and transfer what energy. So basically, I normally say wave is what a disturbance. So a kind of disturbance that travels what energy from one point to what another through what a medium. Now, do you know the funny thing about that medium? Will not be permanently displaced. That means there will be actually what a temporary displacement what in the medium. So when we say medium, that can be solid, liquid, or what gas. Now we should know that wave is what a disturbance that transfer energy. So the next thing, let's look at what classification. Now wave is classified into two categories. Now wave is classified based on what the medium of propagation. It's also classified based on what the directions of what of the between the wave and what and the medium. In terms of the wave, the medium of what propagation. Now let's start with this. When we say direction of wave, I want to understand that the wave and the what medium. The wave has its own direction. The medium also has its own what direction. So that we are talking about two things: the wave motion and the what the medium of propagation. Okay, so now these are the two things that we need to understand for us to actually talk about it: the wave itself and the what the medium of propagation. Are you with me? Now we can also say the wave particles. Okay, now let's go. Now the first thing, which is the direction of the wave. Now this direction of the wave is now divided into two. We have transverse wave and we also have what progressive wave. Are you with me? Now for transverse wave, this is when the wave motion or the wave is actually perpendicular to what the medium. When the wave is perpendicular to the what medium. Examples of this are water wave. You know, there's what we call wave in water. You see water going up and what down. Now you see that up and down. This is actually the wave. The wave motion. Let me just put it that way. Which means that the wave moves from this point to what? To this. But what is that going up and down? That is the water itself. So the water serves as what? The medium. So the water itself is going up and down, but the wave actually moves what? From one point to what another. So typically, I can tell you that this wave motion itself undergoes what we call translational motion. The wave undergoes what? Translational motion. While the medium undergoes what? Vibratory motion. So don't forget, we're basically talking about what? Transverse wave. So transverse wave, this is when the wave is perpendicular to the what? Direction of the what? Propagating medium. When the wave is perpendicular to the direction of what? Propagating medium. So I will take it that the medium, which is water, you can see is going what? Up and down. That's vertical motion. But the wave itself is going what? Horizontally. So look at it. That's perpendicular. So the water, which is the medium, is perpendicular to the what? Direction of the what? Of the motion of the wave. So that's why we call this what? Transverse wave. So an examples of transverse wave, we have the water. Water is a transverse wave. We also have the light wave is a what? Transverse wave. Or we can say all electromagnetic waves. So all electromagnetic waves, water wave, they are what? They are transverse waves. So that is transverse wave. So the next thing, let's talk about what? Longitudinal waves. Now, longitudinal wave, this is when, remember, don't forget, I told you that for you to actually define this direction, we have to talk about the direction of the wave and direction of what? Of the medium. So you guys have now agreed that this medium can be liquid, it can be solid, and it can also be what? Gas. So a typical example, water wave. So which means that our water wave is a what? A transverse wave. I hope you guys get that. Very good. Now let's now go to what longitudinal wave. We still use this wave motion and this medium to define this. Now you will now notice that the wave and the medium, they are parallel. That is, they are moving in the same direction. The wave and the medium, they are what? They are parallel. They are moving in what? In the same direction. And examples of this, you have sound wave. Sound wave is the what? Longitudinal wave. Now let me now make it make sense for you. In this longitudinal wave, make use of this what we call refraction and compression. Now when we say refraction, is a region layers of air are spreading out. But when we say compression, a region of the air, when the layers of air are what? Are joined together. When we say something compressed. So let me give you something like, look at this. Then we will now have something like this. Then we will have something like this. So this layer that is actually spaced out, this is refraction. Why this is what? Compression. So we use refraction compression for longitudinal wave. So you all know sound wave, the one that we're actually hearing, we are hearing because of the presence of what? Air. Which means that without air, we can't hear each other very well. So sound wave can travel through solid, liquid, or what? Gas. I hope I'm making sense. So a typical example of longitudinal wave is what? Sound wave. So I believe with this little explanation, you guys now understand the transverse wave, the what? Longitudinal wave. So transverse wave, longitudinal wave, they are under what? Directions of waves. So if they are types of wave based on direction, that should be transverse and what? Longitudinal waves. So now the next thing, let's look at what? Medium of propagation. Okay guys, so now the classifications of waves, so we are able to talk about directions of what? Wave. So let me just say classification of wave based on directions of wave. That's transverse wave and longitudinal wave. So the next thing I want to look at classifications of wave based on medium of propagation. Now, classification of wave, that means now the thing is that wave is now classified based on the kind of wave that require a medium and those that does not require what? A medium. So wave that require medium, we call them mechanical wave. While those that do not require medium, we call them non-mechanical wave. Now in that non-mechanical wave, that is where electromagnetic wave now falls. So you all notice that in your O level, anytime we're talking about classification of wave based on medium of propagation, they will just say what? Mechanical wave and what? Electromagnetic. Now we also have other type of wave like seismic P and seismic what? X. They are still waves. They are not common. So that's why you notice that anytime we're talking about a classification of wave based on medium, we just say mechanical and electromagnetic. Electromagnetic, these are waves that do not require material medium for their propagation. And when we say medium, you now understand we're talking about solid, liquid, and what? Gas. That means this wave can actually transfer the energy without any medium. But mechanical wave, they require a material medium for their what? Propagation. So now let's look at that. So there is mechanical wave and what? Electromagnetic waves. Now when we say mechanical wave, just like as I told you, I said these are waves that require material medium for their what? Propagation. So examples of this mechanical, we have the sound wave, we also have the water wave, we have wave in spring, we also have wave in string. So wave in spring, wave in what? In string. All these are what? They are mechanical wave. Now look at sound. For sound wave to actually produce, they need the what? Material medium. For water wave to be produced, it need the what? Material medium. Wave in spring, just like you, like drawing spring, you know the spring will actually be what? Vibrating. That is up and down motion. That's wave in spring. Wave in the spring is actually longitudinal. This is longitudinal. Now why wave in string? That is transverse. So this is longitudinal, this is transverse. So in a nutshell, we can say that our sound wave, based on medium, it falls under what? Mechanical. Based on direction, it falls under what? Longitudinal. While water wave is mechanical wave and what? Transverse wave. While a wave in spring is longitudinal and what? Mechanical wave. Wave in string is transverse and what? Mechanical wave. Electromagnetic wave, we now have this set of waves. We have the gazoo. So we have all these are electromagnetic waves. This is gamma ray, this is X-ray, this is ultraviolet ray, light, infrared ray, and microwave, radio ray. Do you know one thing about this? And that's what I want to actually tell you. You see this guy, it has the longest wavelengths. Gamma have what? Shortest wavelength. So which means that wavelength increase in this format. There's an increase in wavelength in this category. Then when we go like this, there's actually what? Increase in what? Frequency. Increase in frequency and increase in what? Penetrations. So which means that our gamma ray has highest frequency, highest penetration. That is why it's only lead block that can actually stop our what? Gamma, that is in radioactivity. But for radio wave, it has the less frequency and less penetrating power. But it has what? Highest wavelength. Now, how do you normally say? We say longer wavelength. So these are our what? Electromagnetic wave. So they do not require material medium for their propagation. So this is everything about classification of waves. So I believe with this, we now understand classification of waves. So the next thing we're going to look at terminologies, that various words that you come across in what? In waves. So we'll be taking them one by one and be telling you how you use them. Okay, so we're looking at terminologies. Just like as I told you, these are the various ways that we will come across in waves. So we're going to start with the first one. We're going to start with amplitude. Now, amplitude, that is the word, the maximum displacement. That's amplitude. What's the symbol? Capital letter what? A. That's amplitude. Now, the next thing we'll be talking about frequency. Now, frequency is the numbers of oscillations or wave that is covered per seconds. Let me come again. The numbers of waves or oscillation which is covered in what? In 1 second. Now, that definition I gave you, that's the formula. So which means that your frequency is what? N over what? T. So this N means the numbers of waves or oscillation per seconds. That's over time. That's frequency. Now, this frequency is also reciprocal of period. That's the reciprocal of what? Period. Now, what is the unit? The unit is hours or per seconds. That's the unit of what? Frequency. In case they ask you what's the dimension, the dimension will be capital letter T is power minus 1. This is the dimension. That's the dimension for frequency. So what did I say again? I say frequency is what? The numbers of waves covers in 1 second. Are you with me? That's frequency, right? So the next one we look at what? Period. So period can be defined as the time taken to cover one wave. That's the time that is required to complete a wave. That's what? Period. So we can now, and what's the symbol for period? That's capital letter what? T. So that means our period can be what? Time taken over what? Numbers of waves or oscillation. So this our period is also the reciprocal of frequency. And what's the unit for period? That is seconds. So we know dimension for this, that will be capital letter what? C. So the next thing we talk about angular frequency. So this is 1, this is 2, and this is what? 3. So 4, angular what? Frequency. So angular frequency, this is the angular displacement. Are you with me? Let me just say the rate of change of what? Angular displacement. That's what we call angular frequency. And it's also the same thing as what? Angular velocity. So we call it angular frequency or angular velocity. So how did I define it? The rate of change of what? Angular displacement. And you know, in physics, anytime we say rate, that means that particular object involves what? Over time. So which means this angular velocity, the symbol is omega. Just W. That's omega. So which means this our angular velocity or angular frequency equals to what? Theta over what? Over T. So this theta is our what? Angular displacement. Why? This is the time taken. That means the angle that wave cover at a time. That's what we call angular velocity or angular frequency. Now this angular frequency, now this is also equals to what? 2 pi f. The question is now, how do we get this? Now look at this. Let me start from here. Okay, now let's start with this. So I say that angular frequency or angular velocity is the rate of change of what? Angular displacement with time. So that means that's omega. This is called omega. And that's the symbol for angular velocity or angular frequency. So anytime you hear angular frequency, angular velocity, we are still talking about what? Omega. That's the symbol. So that means omega equals to what? Angular displacement over time. Now take that. One wave is covered. You know, if one wave is actually covered, that means one cycle is being covered. One wave equals to one cycle. So it means that this theta equivalent to what? 2 pi. That means one cycle. And for it to actually cover one cycle, period is needed. So period is the time required to cover what? A complete cycle. So that's period. So that will be capital letter what? So this 2 pi, that's the angular displacement. So this pi here, it represents radians. We all know that angle can be measured in degree and can also be measured what? In radians. So here we measure our angles in what? In radians. So 2 radians, that's what? The angle that is covered when what? One wave is being completed. And the time required to complete one wave, that's period. So which means that our angular velocity equals to 2 pi over what? T. And we all know that this our T is reciprocal of frequency. So I will now put it there that omega equals to 2 pi over 1 over frequency, right? This will now give us what? 2 pi f. That's how we come across this. So that means our omega equals to 2 pi f and our omega equals to 2 pi over what? And what's the unit for this omega? The unit for omega is rad per seconds. That's the unit for what? Omega. Rad per seconds. Rad per second. That unit for what? Omega. So this is everything about angular frequency or angular velocity. So we can have this angular displacement over time. We can also have this 2 pi f. Why this f means frequency. Then we can also have what? 2 pi over what? T. This capital letter T means what? Period. So this is everything about what? Angular frequency or what? Velocity. So the next thing we're talking about wavelength. Now wavelength is actually what? The distance that is covered. So let me just say the distance covered in completing one wave or in completing what? A cycle. The distance covered, which can actually be the sum of trough and what? Crests. So to cover one wavelength, that will be equivalent to what? Crest and trough. Let me make it make sense for you. Look at this for instance now. You remember when we are talking about classification, I told you that when we talk about transverse wave, what is associated to transverse wave is what? Crest and trough. Now when we say crest, that is the maximum upward displacement. That's crest. Then trough is what? Maximum downward displacement. So and let's say that the sum of this crest and this trough, it gives what? Wavelength. So which means that wavelength is the distance covered to complete one wave, or the distance covered to complete what? One cycle. Wavelength. So now what's the symbol for wavelength? That's lambda. This is the symbol for what? Wavelength. And it is measured in what? In meter. That's the SI unit. Just like your what? Amplitude. So now let's go there. So it means that from this side to this side, you already know that this downward displacement, that's trough, upward displacement, that's what? Crest. So from this side to this side, that will be one wavelength. From here to here, that will be what? One wavelength. Now, but from here to here, that is what? Half wavelengths. Check it. So that's from here to here. That's what? Half wavelength. Now, do you know how we now take it? We take it like this. Look at this crest. It's like half of a cycle. So since it's half of a cycle, that is half wavelength. So look at this crest to trough. This is just like half of a cycle. Join with another half of a cycle. It gives us what? A complete cycle. So a complete cycle will give us what? One wavelength. So that's everything about what? Wavelength. So the next thing we're going to talk about pulse. Let's talk about that quickly. Now pulse. Now when we say pulse, pulse is just like a sudden increase. A sudden what? Increase with what? A rapid fall. Let me give you an example. When you throw stone into water, you will notice that the ripples will suddenly what? Increase. Then after it, what happen? It will die down. That's what we call pulse. Then another thing we talk about phase. Now phase. have to actually understand, like we can have phase and we can also have what? Anti-phase. So if it's, we normally use the term something is in phase or not in phase. Now if I say two particles, that's particles of wave, they are in phase, it simply means that those two particles, they occupies the same position and moving in the same direction. Moving in what? In the same direction. Let me come again. If I say two particles are in phase, it means that those two particles occupies the same position and they move in what? In the same direction. So this aspect, I'll make you guys to understand briefly. So let's expatiate further for you to actually get that part. Now, phase, just like as I said, I told you that phase, we can use it for when they occupy similar position and they are moving in the same direction. We see those particles are what? Are in phase. Are you with me? So now I'm going to draw something for you to actually understand and able to like picture what we're seeing here. Look at this for instance. Now let's look at this. If you look at this B and C with me. Now, but are they moving in the same direction? Let's look at that. If you look at this trend, that means this one is going up, this one should be going what? Down. So it means that B is going where? Up. While C is going where? Down. It means that B and C, they are not in phase. And anything that is not in phase, this will be what? Out of phase. Now, do you know another funny thing? Another funny thing is that if it is out of phase, you need to make us to be talking about phase angle and phase difference. Let's move on. So now, just like as I said these B and C, they are not in what? In phase. That means they are out of phase or anti-phase. Now let's look at B and F. You notice that this B and F, they are on the what? On the same position. This is at the what? At the other side. F is also at the what? Other side. And B is moving up. F is also what? Moving up. So it means that B and F, they are what? They are in phase. Are you with me? Now let's look at C and G. C is coming down, is in the same position as what? As G, and G is also coming down. It means that C and G, they are also in what? In phase. But as for B and C, they are out of phase. Now let's look at D and E. Are they in phase? No, they are not in phase. So we can actually say that what? D and E, they are out of phase. Also, C and D, they are out of phase because they do not occupy similar position. Now, what do we need to now take note very well? Anytime you are looking for something that is in phase, they must have the same position, that is, they must occupy the same position and go in the same direction. But in a case whereby they occupy the same position but go in the opposite direction, out of phase. Look at this B and C. We can even say that they are not in the same position because B is at the what? At the other side. C is what? At the other side. But look at this F. Similar position with what? With B. And going in the same what? Direction. So I think in this now we now understand what is in phase and what is not what in phase. Now let's now expatiate for me. To expatiate further, we need to talk about phase angle and phase difference. Now we have this, we call this phase difference. We call it what? Phase difference. This is called phase difference. And in some cases, we can also refer to as our phase angle. So phase difference or phase angle. But in a nutshell, what should be the phase angle there? Is this, it is sum of this theta plus this what? Phi. Both of them, they are phase angle. But we can still differ this as well. Now, do you know the funny thing? You see this theta and phi, they are the same thing. The only thing that is in respect to something. This one is in respect to displacement. This one, it is in respect to time. Let me come again. This, you know this theta, that's angular displacement. We now understand that this angular displacement. Now, we now understand that this is what? Phase difference. So what's the name of this letter? We'll call it phi. That's the name of that letter. The name of the letter, that's teaching. But here, it is called angular displacement. Here, this one is called what? Phase difference. Now, these two things, they mean one thing, but in respect to different terms or parameters of what? Wave. Let me make you guys understand better. Now we can have this phi to be 2 pi t over what? Capital letter T, and this one refers to our what? That our theta. Now we can also have this phi to be 2 pi x over what? Lambda. This one regards to our normal what? Phase angle. We can see. So that means if I say 2 pi t over capital letter T is a phase, but that phase in respect to time. So since it's in respect to time, we take it as what? Angular displacement. That's the angular what? Displacement. Now, but if it's in respect to displacement, that's what? Phase difference or phase angle. So don't forget, this theta and phi, both of them can still be what? Your phase angle. So now let's now take it bit by bit. Okay, so now we're still talking about the phase difference, right? So our phase difference, let me write it full. Okay, our phase difference, just like I told you, that phi equals to 2 pi x over what? Over lambda. So we have now understand the fact that this theta and this phi, they still mean the same thing. But this one is in respect to time. That's why it refers to as angular displacement. While this one is in respect to displacement. That's why it refers to as what? Phi or phase difference. So this is phase difference and this is what? Angular displacement. So I cannot write that theta equals to what? 2 pi t over what? Period. That's theta and this is what? Now, how does this guys comes in? That's a very good question. Now, this is it from here to this point. That's displacement. From here to this point, that's what? The displacement of that wave. If you look at B and C, here you get. Okay, let me say we're talking about B and C. Let's talk about, so you guys now understand, we don't know what is phase angle. So phase angle is still the same thing as what? Phase difference. Very good. So this is our phase difference or phase angle, which is 2 pi x over what? Lambda. And now this is what? Angular displacement, which is 2 pi t over what? Period. So you know that this is also phase angle. But because this one has in respect to time, that's why we call this one what? Angular displacement. You can see this is our phase angle and this one is what? Our angular displacement. Okay, now let's look at this diagram. So we already know that this A and M out of phase because they are not in the same position. Now look at A and C is also out of phase. They are not in the same position and they are not moving in the same direction. Now let's look at A and B. They are in what? In phase. A is at the other side. B is also at the other side. Or we can say A is at the left hand side. B is also at the what? Left hand side. And opposite A and B. A is going up, B is also going up. They are in phase. C and D, they are in phase. You know why? Because they are on the right side. So C is going down, D is also going where? Down. M and N, same position, going in the same direction. M and N is what? In phase. Okay, now let's now look at A and M. Are they in phase? No, they are not in the same position. Now A and M, that means it is out of phase. So now, anytime you're talking about something is out of phase, you have to know the phase angle or the phase difference between this. Now, how will I know that? That's what we want to do now. Look at this. You first of all come here that your phi equals to 2 pi x over what? Over lambda. Please permit me to write this. This is our pi. Okay, now let's go. Now, you know that from this side to here, to this part, that is our displacement. That's how far the wave have traveled so far. So we know that from this A to this B, that's wavelength. That's the displacement covers in one wave. That's how far one wave have actually traveled. So from A to B, that's one wave. And that will actually give us what? One wavelength. So which means that this diagram as a whole, that's 2 wavelengths. Because from there, it makes sense for you. One full cycle is one wavelength. At the up, half cycle. Join this half cycle to this, that gives you what? A full cycle. That's one wavelength. This and that, shake it from here. That's what? 2 wavelengths. So which means that this diagram I have, this is 2 wavelengths. Now, the question is, I want to A and M. I know they are out of phase. Please permit me to clean this. A and M, they are out of phase. Very good. So we want to know what is the phase angle there. Now look at this. First, you have to come to the what? The displacement. You ask yourself, what's the displacement between A and M? You know that from this A to B, that's one wavelength, IB, because that's a full cycle. Now the question is now from A to C, that's what? Half wavelength, because that's what? Half a cycle. Now for A to M, that should be quarter of a cycle. So which means that this X, that should be what? 1/4 of wavelengths. That is the displacement from A to M. So since you now know that, you now come here that your file equals to 2 pi. What's your displacement? That's 1/4 of wavelength. Abi over what? Lambda. That's wavelength. So what happened? This wavelength we cancel this what? Wavelength. This will now be what? 2 pi over 1/4. So we all know that this is actually going to give us 5 equals to what? 2 pi over 4, right? So 2 in here, 2 in here. So our file will actually be equals to what? Pi over 2. We are not done. Since you know that your file is equal to pi over 2, we are not done. Remember, it now depends if they're asking your angles in terms of pi or they want to give you angles in terms of a degree. If they ask the angle in terms of pi, that means you are leaving the angles in radians. But you look at in your option, you are not seeing degree. Don't panic. Now, I want to actually know that when you say 2 pi, that's for a full cycle. Remember, I told you circumference of a cycle, that's 2 pi what? R. Is it this 2 pi there? It represents the total angles of that full cycle. Because you know that I have to turn a complete cycle for me to have the circumference, right? So that 2 pi there represents what? The total angles, that's the angular displacement. So 2 pi for a full cycle, that's 360 degrees. So 1 pi, that's what? Half. I mean, we already know that. That will be 180 degrees. So pi over 2, that should be what? 90 degrees. So pi over 4, that should be what? 45 degrees. So that's it. So 2 pi, that's 360 degrees. 1 pi, 180 degrees. Half pi, 90 degrees. Pi over 4, that's 45 degrees. Automatically, so this means that this is half pi. So what's our half pi? 90 degrees. Or you can also, since you know that 1 pi is 180, you can just put it there, 180 divided by 2. So the phase angle between A and M, that's 90 degrees. That's it. The phase angle between what? A and M, that's 90 degrees. So I want you on your own, try it. What is the phase angle between M to N? So for me, I'll be trying the phase angle between A and B. We'll be doing that here. Now, remember, we just find the phase angle for A and M. And we find that phi equals to what? 90 degrees. So now we want to look for the phase angle between A and B. A and what? B. We want to look for the what? The phase angle. So we know that our phase angle, that's what? 2 pi x over what? Lambda. Right? So we'll find our what? Our displacement. Now, from this A to B, what will be the displacement there? We already know that's one wavelength, right? So it means that's what? One wavelength. So you just put it there that our phi equals to 2 pi lambda over what? Lambda. So lambda cancel lambda. So it means that that phi is what? Is 360 degrees. Now let me, any particle that has a phase angle of 0 degree or 360 degree, those particles will be in phase to the starting particle. It will be in what? In phase. They will always be in what? In phase. So any particle that has 0 degree or 60 degree, they will always be what? In phase. Phase to what? The starting point. So the phase angle of this A, we are starting from 0. The phase angle of A, that should be 0 degree. So the phase angle of M, so now M, displacement from M to A, because A is the starting point. So the phase angle of M, that should be what we actually found, that should be what? 90 degrees. The phase angles of this B, that's what we just find now. So the phase angle of B, so that the displacement from B towards A, or displacement of this B from where? From A. That's one wavelength. So we just find out that that's what? 360 degrees. So it actually means that this B will be in phase with what? A. Are you guys with me? So the B will be in phase with what? A. So don't forget, I said you should go and find what? The phase angle of N. Find the phase angles of what? Of D. So you can find the face angle of N, face angle of what? D. So if you want to take displacement, you'll be taking displacement from this. But if they ask you the face angle to M, so they say M to N, know if they are in phase or not in phase. You just take your displacement from the starting point. So I'll be leaving you guys with that. So I will now bring a questions based on this out for you. So I think I'll have the question. Okay. So now in this question, so there are P, Q, and W. We should know if they are in phase or they are not in phase, and we should find their what? Their phase angle. You should also find the phase angle. So you see the questions to appear on the. So the P, Q, and W. Now you should find the what? The phase angle. The next one, P and Q, then V and Y. We should also find the what? The phase angle. You can see the letter. Then and the next question which I'm taking is straight. They say which points will be 270 degree out of phase. Amongst all these, which point will be 270 degree out of phase? So we're looking at this first. Now let's look at P and what? W. Now this P and Q, are they in phase? Obviously, we should actually see that P and Q, they are not in phase. Now what about P and W? Are they in phase? Now P and W and Q, they are also not in phase. Now V and Y, they are also not in. But these are phase angle can actually tell us. So we now know that anytime we have a particle to have 0 degree or to have 360 degree, those particles definitely be what? In phase. Okay? So now let's look at that. Let's start with what? P, Q, and what? And W. Now, obviously, the phase angle of P, that should actually be what? 0 degree, because that's the starting point. And at that starting point, we have 0 displacement. We have what? 0 displacement. Share again. So let me just put it for you to actually make it sense. That will be 2 pi x over what? Over lambda. So since the displacement is 0, that will actually be what? 2 pi 0 over what? Lambda. So everything goes 0. So the phase angles of P, that's 0 degree. Because that is actually the starting point. So the next one, let's go to what? Q. So we're solving it at this up. So let's go to what? Our Q. Okay, now let's solve it in this up. Now look at that Q. The phase angles of what? Q, right? And obviously that should be what? 2 pi x over what? Lambda, right? Now from this P, look at Q. This is Q, right? So Q to P, that should be quarter of a wavelength. Because we know that from P to R, that's the what? Okay, so now we want to look at what is the phase angle for this W. Now we are going to take the displacement from W to P. So we know from P to V, that's half. From P to W, that should be what? 1.5, right? Remember we're talking about W, right? So the X, that should be what? 1.5 wavelengths. So 1.5 wavelength, that equivalent to what? 3/2 wavelengths, right? Very good. So since that's equivalent to 3/2 wavelength, then what's the file will be? That will be what? 2 pi x over what? Lambda, right? So that will be equal to what? 2 pi. Then you put this 3/2 what? Lambda in the bracket, then over what? Lambda. So what will happen? Lambda will cancel lambda. So you now have that 2 pi times 3/2. So 2 cancel 2. So you have what? 3 pi. So 3 pi means it means. So that 3 there, that will be 3 times what? 180 degree. Which will actually give us what? 540 degree. Are you with me? We all know that this 540 degree is more than 360. Are we? So since it's actually more than 360, closer, what will you do? You say 540 minus 360. So 540 minus that 360, you have a what? 180 degree there. So 180 degree or 540. So the phase angle of this W is what? 180 degree or 5. Is also what? Out of phase towards P. Is what? Out of phase towards P. So now that's so we are able to find the phase angle of P, the phase angle of Q, the phase angle of W. So these three guys, they are out of phase. Now let's look for here P also we are finding, Q also we are finding. So the question is that P and Q, are they in phase? No, they are out of phase. So I will leave you guys with this. Look for the phase angles of V and the phase angles of what? Y. and drop it in the comment section. Let's look at this next question. They say, which point will be 270 degrees out of phase? I don't know. Now we're giving the phase angle, but they want to know the particular points that it is. Now what am I going to do? I'm going to get the displacements for that point. Now when we now get displacement, you will now be the one to tell us the point there. So you tell me in the comment section the point that is out of phase with 270 degrees. With the wavelength, you will get that, and that will be actually be easy for you. Now let's do that. You know your phase angle equals what? 2 pi x over what? Lambda b. So your phase angle is already given. So you just write it there that 270 degrees equals to 2 pi abi over what? Over lambda, right? We already know this as well. So we know that this 2 pi is 360. You can solve it in terms of radian, and you can also solve it in terms of what? Of degree. I'm solving it in terms of degree. I will now say 270 degrees equals to let me write it down. I will say 270 degrees equals to 360 degrees x over what? Lambda. What will I do? I will just cross multiply. So if I cross multiply, remember what I'm looking for? I'm looking for what? The displacement. So if I cross multiply, I will have 270 degree wavelength equals to 360 degree x. Abi 270 degree wavelength equals to 360 degree what? X, right? Very good. 270 degree wavelength equals to 360 degree x. Remember what we are looking for is displacement. So what will happen? Divide both sides with what? 360 degree. So we now have x equals to 270 degree wavelength over 360 degree. So what we just do? Oh, go ahead. So I think 90 in this, that will actually give us 3. So 90 in this, that will give us what? 4, right? So therefore, it means that your x, that's your displacement, is 3 over 4 wavelengths. And 3 over 4 wavelengths, that should be half and quarter. 3 over 4 wavelengths, that should be what? Half and what? Quarter. And that's half wavelength plus what? Quarter. Are you with me? Half wavelength plus what? Quarter. That means just what? Half, and let me say half and quarter. So which of the particles have that phase angle? So drop your answer in the comment section. Okay, so that is that about our phase and phase angle and phase difference. So with this, I hope we now understand phase angle, phase difference, and how to find it. So with this video, you guys now understand how to find your phase angle, how to know which one is in phase and which one is not what. The next one we'll be talking about velocity. Now let's talk about velocity. Now, as we all know, velocity, that's the what? The displacement covers in 1 second. The displacement covers in what? In 1 second. Put in the shade. That means the wave covers in what? In 1 second. Or we can actually say that wavelengths. The wavelengths that is actually what? Displacement covers in what? In 1 second. So our velocity, it can also be equal to f what? Lambda. And velocity can also be equal to what? Lambda over what? Period. We can have, so we can have velocity equals to f, that's frequency times wavelength. Velocity equals to what? Lambda over what? Period. Are you with me? And what's the unit? That's meter per second. So that's everything about the terminology. So next, we'll be moving to progressive wave. So now, we have actually talked about classification. We have another classifications of wave that's based on the classified wave into progressive or traveling wave, and we also have standing or stationary wave. Now, you see, standing or stationary wave, these are waves that do not move, but they transfer energy within what is. But you see, for progressive wave or traveling wave, they move from one point to what? Another, and that's where we have this. So progressive wave, they move from what? One point to what? Another. They can move the wave, they move horizontally, right? So we now have the negative side for x and the positive side for what? For x. Negative side for x and positive side for what? X. So wave can move from this negative to what? Positive, and they can also move from positive to what? To this. Now, what I want to now to be noticing your file. Look at it. If this your file is actually negative, it actually means that the wave is starting from negative. Because you know that this is your phase angle. It means that the wave starts from negative going to where? Positive. That kind of wave will actually be what? Positive x-axis. But if your phi is actually positive, that actually means that the wave starts from positive and move to where? Negative. That kind of wave will what? Negative axis. Now look at this phi. Look at this equation. Y equals to a sine theta plus phi, right? What is the case to phi is positive? It means that the wave will move towards negative axis. Look at this. The phi is negative. It means that the wave moves towards positive axis. So that, I think that should be what? Clear. So negative axis, positive what? Axis. So now you can have a lot of equations. They will not be telling which of this is correct. For a wave traveling towards negative axis. So if they take a wave traveling to negative axis, you should know that the wave starts from somewhere. Because it does not just get to negative axis. Where does it start from? Positive axis. How will you know that? It's phase angle. Because phase angle, that is the starting angle. So if the phase angle is negative, it means that the wave starts from negative and it will end what? In positive. But if the phase angle is positive, it means that the wave starts from a positive side and it will end what? In negative side. Is that clear? So that is that about the. So now we now have a lot of equations. See, this y represent our what? Our vertical displacement, which is for the what? For the medium, because the medium goes up and what? And just like a water, it goes up, it goes down, it goes up, it goes down, but the energy is transferred what? Horizontally. So now this A, that represents our what? Our amplitude. A represents our what? Our amplitude. Why this theta? That represents what? Angular displacement, which is actually what? 2 pi t over what? Period, right? And it's also equals to what? WT. From there, we now know that our W is what? 2 pi f, right? Okay, so let's take it step by step. This our theta is what? WT, right? Then our W is what? 2 pi f, right? So I can now write it as 2 pi ft. And what is our f? Reciprocal of what? Period, right? So we can still write it that our theta, which is our angular displacement, equals to what? 2 pi t over what? Capital letter T. Since this frequency means reciprocal of period. These are everything for the words angular displacement. Why for the phi? That should be what? 2 pi x over what? Lambda. Are you with me? Now you now see this 2 pi over lambda. That's also called another thing which we call k, which we call wave number. We call it what? Wave number. We can also call it what? Phase constant. We also call it what? Phase constant. So it's called wave number, phase constant. Wave number, phase constant. Why this is called what? Phase angle. So this is called wave number, phase constant. Wave number, phase constant. So our phi is what? 2 pi x over lambda. Why this is what? The displacement. This is what? Displacement. Now also know your phi can also be equal to 2 pi change in displacement over what? Time. And when we now say change in the displacement, that can now be that x2 minus what? X1. Now, in case whereby they will tell you that between the two layers of the wave, this find the phase angles. Are you with me? Two displacement. Are you with me? They will not tell you find this phase angle. Just subtract the big one from the smaller one. You have get this. Then put everything here. You will get your what? Your phase, and you actually have your wavelength. You will give you wavelength, and then now give two displacements. You can use that to get your phase angle. Okay, so that's now all these things, and I cannot put it into this equation. So we have now established the fact that our phi can be equals to kx and can also be equals to what? 2 pi x over what? Over lambda, right? So since now I can now write this to be y equals to a sine, then in the bracket kn, so that will be what? What was that? Wt, abi, minus what? Ks. Shall you get? So this is general equation. So we can have this. Wt represents what? This angular displacement. Are you with me? The Wt represents that angular displacement. Why this for what? The phase angle. That this for what? The phase angle, right? So this phase angle, this for angular displacement, phase angle, angular displacement, right? Now we can also have this to be y equals to a sine in the bracket. This will be 2 pi t over what? T, right? minus what? 2 pi x over what? Lambda. Now we can remove this pi, we can put this pi outside. So if we put this pi outside, you know what that will be? That will be y equals to what? A sine, 2 pi, right? Then we have t over what? Big T minus what? X over what? Lambda. We can have this. Okay, so we can have this equation, we can have this equation, we can also have this equation. Now, we can also have this. Now, another thing I want to actually tell you, this our wave number or phase constant is also equals to angular velocity over linear velocity. Our phase constant or phase wave number is also equals to what? Angular velocity over what? Linear velocity. That means that our angular velocity will now be what? kv. Now look at everything that I did. Now we can also use this to solve some other questions. Now look at everything. I will not start back from me again. Y equals to a sine wt. Now I can say plus and minus ks because depending on the direction of the what of the wave, right? It can be a positive wave, it can be what? A negative wave. So you know, but the most common one is the minus. So that one that the ks is actually minus, it means that such wave is traveling towards positive x-axis. But that one that the ks is plus, the ks represent the 5. If it is plus, it means that such wave is traveling towards negative x-axis. Okay, now let's now go. What's our k? Now k is what? W over what? V, right? And what's our w? Kv. Now look at what will happen. I will now go like this. Y equals to a sine, then in the bracket w, that's what? Kvt, right? Then just use minus what? Kx. What is common here? Kk. So that will now be y equals to what? A sine, then k in the bracket vt minus what? X. So this is another equation. Now I won't want you guys to cram. Just know one. Are you with me? And know how to what? Apply it. So know this and know this. Once you know this, other one. You already know that this your k is actually 2 pi over what? Lambda. So once you know this and this, you are supposed to go. And you know that this, either these two, is the what? The general progressive wave equation. Be familiarized with this and know this. You don't need to cram all the formula. Just know these three. Look at the question that pop up on the screen. So we'll actually be solving that questions. Now, in that question, you were told to look for the amplitude, the frequency, the period, wavelength, and velocity. So we'll be taking it one by one. The equation in that question, so I just put out the equation out. Now the equation there, they give us an equation there. They say y equals to 5 sine pi, then 3x minus what? 4t. Looking at this equation, and they also ask us to tell them if it is actual, you should tell them if it's a negative axis that you will be traveling to, or it will be traveling towards positive axis. First, let's understand which of the equation I'm going to use this. Looking at this, assuming that this will be y equals to 5. This pi, I'll bring it inside. So now be what? Sine equals to 5 sine in the bracket 3 pi x minus what? 4 pi t. Now what I've just written now, why equals now, what did I do? I bring this pi into the bracket again. So I use pi to multiply this. That will now give me 3 pi x minus 4 pi t. What I've just written now, simply tell me this is going to be y equals to a sine in the bracket. We already know the one that is associated with it, that's what? Kx. That's the one that is associated with what? X. That will now be minus what? Wt. The one associated with t is what? Is w. K with what? X. W with what? With t. Now looking at this, it means our phi, which is actually kx, are you with me? Our phi, which is ks, is positive, which means that this wave is traveling towards negative x-axis. Since your phi is positive, and you know from positive towards negative, it's traveling towards negative x-axis. That's what it simply means. Now let's solve for the what? The amplitude. For the amplitude, that's actually what? 5 meters. Another thing, you need to consider the what? The unit you will give. If they tell you that the displacement in meter, the amplitude, you need to consider that. So in this question, I think the amplitude is in what? In millimeter. So A equals to what? 5 millimeter. That's it. Then the next we should look for the what? The frequency. Now to get my frequency, I'll use this. Now, since I have WT, I can say WT equals to what? 4 pi T, right? T cancel T. So it means W equals to what? 4 pi, right? Now, if W is actually equal to, this same W equals to what? 2 pi F, right? So what would I do? I will now say 2 pi F equals to what? 4 pi. What will happen? Pi cancel pi. Are you with me? 2 here. So my frequency equals to what? 2 as. That's my frequency. Now I've gotten the frequency. Next I want to look for the what? The period. And that's very easy. We all know that your period is reciprocal of frequency. What would I do? That will be 1/2, right? So 1/2, that should be what? 0.5 seconds. So my frequency is 2 as, my period is what? Is 0.5 seconds. What's the next thing? We expect to look for the wavelengths. Now to look for wavelength, there's a relationship between frequency and wavelengths and velocity. So velocity equals to frequency times what? Wavelength. Are we? Very good. We are still coming back to this. Now, we are meant to look for the wavelength. Look at this Ks. Ks equals to what? 2 pi x over what? Lambda. Which means my K is 2 pi over lambda. If I remove x, K equals to what? 2 pi over lambda. So in our question here, our K is what? 3 pi. Our K is what? If you should remove x, your K is what? 3 pi. So I'll just go to the point. I'll just write K equals to what? 3 pi, right? So if K is 3 pi, and what's our K? That's 2 pi over what? Lambda. That equals to what? 3 pi, right? So what happens? Pi cancel pi over, and then it equals multiply. So that will actually be what? 3 lambda equals to what? 2. Then lambda equals to what? 2 over 3 meter. Are you with me? So your lambda equals to what? 2 over 3 meter. I haven't got it that. The next thing we are meant to get our velocity. That's where we now use this. So now to now get our velocity, that will be the frequency, which is 2 what? As times what? The wavelength, which is what? 3 and 2 over 3, right? So your velocity will actually be what? 4 over 3 meter per seconds. Now what did I do? I saw everything in meter. So the idea here is for you to actually like know how to solve it. So if you see a particular question, just understand what they're asking to and understand the kind of equation you are going to use. So what is the most important thing there? Having seen the equation, understand, okay, out of the 3 equations I asked you to know, from that 3 equations, you just pick one of them. Okay, this one tally with this. Then you can now be using that to compare and you solve everything. So these are the kind of questions that they can actually ask you. So we have solved everything. So they can ask you 1 or 2 of these parameters, either the amplitude, the frequency, the wavelength, the period, or velocity. So since this particular, so that's, we are done with progressive wave. So under this progressive wave, we're talking about the progressive wave equation with me. Then let's talk about how to, if you see a graph, how can you use that graph to solve questions. So we'll put that under calculation. So let's talk about the properties of wave. So in the properties of wave, we have reflection. Wave undergoes deflection, and it also undergoes what? Diffraction. Let me come again. Reflection, refraction, then interference, diffractions. Then polarization is a property that is actually common to what? Only transverse wave. Polarization is common to what? Only transverse wave. Longitudinal wave do not undergo what we call polarization. Then, is it progressive wave? It can occur in both longitudinal and transverse wave. So both longitudinal and transverse wave, both of them undergoes what? Progressive wave. Now let's look at this. I want to use it to explain the kind of calculation you can make in case you come across a graph. If you have been following up the video, you notice that it's actually very, very simple. Now let's go on. Just like as I told you, this vertical side represents what? The vertical displacement. That's for the medium. The medium vibrates. The medium vibrates or oscillates. While for the wave goes horizontally. So remember, I told you this is crest. This is what? Trough. Crest, trough. These are for what? Transverse wave. In a nutshell, that means what I just drew. This is a demonstration of a progressive wave. Between. Okay, now look at this. From this point to this point, this can be a displacement and it can also be what? Time. That means this side, it can be displacement, it can be what? Time. So here I'm using displacement. So now from this part to this part, that's one wavelength. Then from here to here, that's what? Half of wavelength. Let me just say over 2. That's half of wavelength. Are you with me? From here to here, that's half of wavelength. Now from this part, that's from this side to here, that's quarter of wavelength. So let me come again. From this part to this part, that's why I told you that crest and trough. So if you want to define, you can say wavelength can be defined as the sum of a successive crest and what? Successive trough. Wavelength can also be what? The sum of 2 crests. It can also be what? The sum of 2 trough. It can be crest and crest, that's one wavelength. It can be trough and trough, that's what? One wavelength. Now let's make it make sense. So from here to here, that's one wavelength. From here to here, that's half wavelength. From here to here, that's quarter of what? Of wavelength. So now the question is now this total displacement, that's from here to here, how many wavelengths is here? This should be 2 wavelengths. So in a nutshell, that S equals to what? 2 wavelengths. So this S equals to what? N times wavelength. That's X equals to numbers of wave times the what? Wavelength. S equals to numbers of wave times the what? Wavelength. Now, if we are not regarding to time, are you with me? If it is time will be what? N times period. Let me make sense for you. So this one is in respect to what? Distance. Are we? If it is now, we are talking about this will not be like this. This will still be Y. This will not be time. That's in seconds. Shall you get? So X here will be what? N times period. I will say. Now, why did I tell this? You notice that they will give you that. They will give you something like this. They will not tell you that if this is 5 meters, what is the wavelength? If you have from here to here 5 meters, what is the wavelength? And you know this is what you actually have here. That's not a wavelength. How do you know? Because this is not one wave. No, or not what? One cycle. This is more than one cycle or one wave. So if you want to get the wavelength, what will you do? Just say that okay, S equals to what? N times what? Lambda, right? What you are looking for is what? Lambda. The question is that how many waves is there? Look at it. 1, 2. This is 2.5. So it means that your X will be equal to what? 2.5 wavelength. So to now get that wavelength will now be what? X over what? 2.5. That means, in a nutshell, our wavelength equals to what? X over the numbers of the wave. Our wavelength equals to what? X over the numbers of wave. So the wavelength equals to what's X? That will be 5 meters divided by what? 2.5. Are you with me? So 5 meters divided by 2.5, that should be what? 2 meters. So it means that the wavelength equals to what? 2 meters. And they can also ask you for frequency and that thing. So with this, you should be able to solve any question relating to what? Diagram. So that's about the calculation. So thank you guys. So we're able to complete everything on that wave. And let's see guys, with this little that you have actually learned, now go through your past question. Now you now see that it will actually be what? Clear to you. So thank you for following us, and please subscribe, and anything that you understand or any topic that you want us to do in the next section, you can drop it in the comment section.